Let's look at the initiate and decide phase of the software construction process. Here we need to have a look at or determine what we're going to do, what we need. With the expression of the software, the format of the software is rather determined by the language concerned, so we don't need to worry too much about that. What we do need to be concerned about is the coding standards. All right? How will they be expressed and how will they be recorded in such a fashion that people who need to see them can see them easily and can understand them and apply them? The coding standards, there are, all you need to do is Google coding standards or coding styles, and you'll find plenty of them. So there are competing ones. However, they seem to break down the standards, or the matters covered within the standards break down into three groups. There are naming conventions, and usually the naming conventions are there so that when you look at the name of something, you know what it is. So a character variable will have something that indicates that it's a character variable, and an integer will indicate it's an integer. Aside from that, there are conventions about what has uppercase letters and lowercase letters, depending whether it's, say, a class or an object or a function or a label or something of that nature. So naming conventions are something that normally occur in coding standards. You have to decide which naming conventions you're going to adopt. The second thing that's covered in coding standards is formatting. This is just so that when somebody's reading the code, it's easy to read, easy to understand, and you know where things are. Now, a certain amount of this started out with C, where indentation mattered. I think it might occur also in other recursive languages such as Algol and at the moment I can't think of any others, probably Java as well. But the indentation seemed to be a recurring scheme. I know with Lisp, indentation sort of mattered because everything was enclosed in brackets, and you could get nesting to a large number of levels, and so it became very difficult to keep track of. Did you have all of the brackets there? So the format matters. It helps if you have some formatting conventions, usually the indents and where you match the braces to indicate the closure of things. The other convention is which elements of the language are you going to use. Now this is because powerful languages have powerful constructs. That power comes with the ability to make really big mistakes. And there are some elements of, or some constructs in a language that enable you to get into trouble. The one that caused most problems within C was the alloc and free. Memory leaks were infamous, and it has been noted that languages that automatically take care of allocation and garbage collection have something like 70% less errors than languages that don't. So use of the language, things are usually covered by the standards, and it's it is not to be a nuisance, it is to keep you out of trouble. Something that you may need to consider is continuous inspection. Are you going to do something like pair programming, or are you going to, by convention, have your code reviewed by somebody? Or are you going to devise automated unit tests? Or are you just going to code it, ship it, and hope for the best? This is something you should decide about how you're going to construct your software. The third thing that you do need to consider at this stage, in the initial stages of software construction, is whether and when you're going to refactor the software. Now, with agile development, you have the opportunity to go back and fix your mistakes, and some of the mistakes are going to cause structural changes, and this causes refactoring. You can't anticipate everything at the beginning. It's likely you're going to have something that you implement with a fix a kludge or a temporary measure. You will need to go back and deal with those temporary measures, but the question is, when are you going to do it, and what effort are you going to devote to it? So that's something to be decided at the beginning of the software construction process. The next thing that will need to be decided, particularly in agile software development, one that comes up all the time, is the definition of done. When is this component, this piece of code, considered to be done, complete? Is it when coding has finished? Is it when it compiles? Is it when it's been tested? Is it when it's been tested and reviewed by other people? Is it when it's been incorporated, integrated? Is it when it's been shipped? Is it when the customer has accepted it? What is the definition of done? It's useful to have that so that there is some agreement on the measure of progress and the status of task in the system. So that if something has gone out of doing into done, everybody knows what it means. Now there are places where you can get more information, and I've recorded them there. Increasingly now there's tools like Sonar being used, and there's information about refactoring that can be done. And a lot of the development environments have more or less continuous inspection associated with them. So in summary then, what we're trying to do is write code that works, that we can be proud of, and that can be maintained and modified without breaking. To do that is hard, and good professionals do manage to do it. Writing the code is easy. As I said, high school kids write code. Checking that code works and won't break, that's the hard part. And the other thing to bear in mind is refactoring. Sometimes it's referred to as fixing the technical debt, but refactoring is something to be done.